Hi, my name is Reagan, and today we're going to be doing Experiment 8, Calorimetry and Hess's Law. Most chemical and physical processes are accompanied by a change in energy of some kind. This change of energy can either be heat absorbed or lost, it can be light produced, or even an electrical energy. To measure the heat lost or gained in a reaction, we use a technique known as calorimetry. A calorimeter is a vessel that is insulated from the exterior surroundings so as to measure the heat lost or produced in a reaction under isolated conditions. Today, we're going to be doing a couple of experiments using a homemade calorimeter using a styrofoam coffee cup. According to the first law of thermodynamics, the heat lost from a reaction must be gained by the surroundings from that reaction. It is preserved or conserved no matter where the heat goes. When heat is lost from a reaction and absorbed by the surroundings, it is an exothermic reaction. This is similar to a campfire, for instance, releasing heat into the environment. When heat is gained in a reaction, it is known as an endothermic reaction, and it pulls in heat from its outside surroundings. We're going to be doing a couple of exothermic reactions, first by calibrating our calorimeter using some copper slugs or cylinders that we'll be heating and then putting into a water sample which will then absorb the heat from those copper cylinders. And then we'll also be doing a experiment where we neutralize a strong acid, hydrochloric acid, with sodium hydroxide, which will then also produce heat, and we'll be measuring the heat lost to the surroundings via that reaction. Before we get started, we need to talk about safety in the lab. We need to make sure that we're wearing our lab coat that's been buttoned all the way up. Any loose hair is tied back. We are wearing long pants with closed-toed shoes that has no skin showing below our waist. That includes wearing pants that cover the ankles and wearing shoes that cover your toes. Always make sure to wear your goggles during experiments and gloves as well. Today we're going to be using a hot plate, so you need to be mindful of the heat that's being produced so as not to burn yourself. And we'll be adding a strong acid to water. And when you do so, you want to make sure you always add the acid to the water because that is very exothermic, meaning it produces heat. And if you add water to a strong acid, it can then bubble up and it might splash onto your person. So please be mindful of those safety considerations while we proceed with this lab. So let's get started. So for this lab, you're going to need 2 solutions, 3 molar sodium hydroxide, 3 molar hydrochloric acid. You'll need some distilled water, a graduated cylinder, a volumetric pipette and a pipetter, a 25 millimeter test tube with 2 copper cylinders, some styrofoam coffee cups and lids, a balance, your MicroLab instrument, your computer that has the MicroLab software on it, and a hot plate with a 600 milliliter beaker filled about halfway with water for a hot water bath. So before we begin the neutralization experiment, we need to calibrate our homemade calorimeter, which in this case is a styrofoam cup, using 2 copper cylinders like these. To begin, we need to weigh out these cylinders so that we can know how much heat is being transferred due to their mass. So we need to first open the lid on the balance and then zero the balance. And once the balance has been zeroed out, we can then set our copper cylinders on the balance and record the reading to the nearest 1/10 of a gram. You want to write that down in your lab book and then add those copper cylinders to a test tube by sliding them in carefully so as not to break the test tube. And add them to a water bath that you have boiling off to the side. It's wise to get the water bath started early in the lab so that way you don't have to wait for a long time for the water to boil. So after we add the copper cylinders to a test tube, we can then place it into a water bath that we have boiling here off to the side. And while the copper cylinders come up to equilibrium with the boiling temperature, we can start the MicroLab software and prepare it for the experiment that we're about to do. So on your computer, you can open the MicroLab software and hit MicroLab Experiment. After opening the program, you need to add two sensors. The first is a thermistor, or a temperature probe in this case. So we will go to Add Sensor and choose Thermistor. And then we will choose our input. In this case, it is plugged into A. And we will use the factory calibration. We will then add our second sensor, which is time. And we'll choose our timer, which doesn't really matter, so you can choose 1. And go to Set Timer Options, and then accept the options by hitting Finish. Once you have done that, you'll want to go to the bottom left-hand side and change it from repeat every half a second to repeat every 1 second. That setting will tell the computer how often to take a reading of the temperature that we're doing. Finally, you need to drag the thermistor over to the y-axis and time over to the x-axis. And then likewise in the spreadsheet on the bottom, you need to add time to column A and then add thermistor to column B. Your thermistor should already be taking readings of our boiling liquid here. It shows it's at 97 degrees Celsius, which is lower than you'd expect due to the elevation. And we're going to let it sit there for about 4 or 5 minutes so that the copper cylinders can come up to about 97 degrees Celsius before we start the calorimetry calibration. So while the copper cylinders are coming up to temperature, we can weigh our styrofoam cup here first, so that way we know what mass we're starting with before we add the water. So you'll want to zero out the scale and then add it to the scale, and then write down to the nearest tenth of a gram the mass of the styrofoam cup. And then using a graduated cylinder, measure out 60 milliliters of water, and then add that to the styrofoam cup as well. Once you have added the water to the styrofoam cup, you can then reweigh it, and by subtracting the mass of the styrofoam cup alone, you'll know exactly the mass of water that you added to your cup. After you've added your 60 milliliters of water to your cup, you can then place it in a 400 milliliter beaker to keep it stable during the experiment. And then using a lid, slide your probe through the hole so that it is just touching the liquid in the cup, but not the sides of the cup. You can put the lid off to the side so that way you're ready to add your copper cylinders when they're done heating on the hot plate. So once your cylinders have been in the boiling water for about 4 or 5 minutes, you want to first hit start on your MicroLab software to begin recording the temperature of the probe that is in your water. And then as that begins running, remove your test tube from the water, wipe it off, and then add your cylinders into your styrofoam cup. You can then put the lid on to prevent any heat from escaping into the atmosphere and not being measured by your water. So you'll want to continue taking recordings until the temperature starts to fall off inside the cup. At that point, you know that the copper cylinders are no longer providing heat to the cup, but is now being lost and it's starting to cool. So once the temperature started to decrease in your cup, you can then stop the experiment and save your data, and then remove the probe from your cup and remove your cup from the beaker. So the last part of the experiment is similar to the first, but this time we're going to be using 3 molar hydrochloric acid and 3 molar sodium hydroxide to do a neutralization reaction where the base and the acid neutralize each other to form salt water, basically. Using the same styrofoam cup, first we need to weigh the cup so that way we know exactly how much water we've added. So if we weigh out our cup, we can record it to the nearest tenth of a gram. And then we can add 50 milliliters of distilled water to our cup that we measured out using a graduated cylinder. We then need to add 10 milliliters of hydrochloric acid using a volumetric pipette. So you'll need to get 3 molar hydrochloric acid from your TA, and you can first add about 20 milliliters of that hydrochloric acid to a small beaker. You'll need about 20 milliliters because we're going to be rinsing the volumetric pipette, and we'll use 10 milliliters for the experiment. So we have our volumetric pipette and our pipetter, and we'll first want to draw up a little bit of the hydrochloric acid till the bottom of the bulb here. So that way we can rinse it on the inside and then expel the hydrochloric acid into a waste beaker. You'll then need to draw up 10 milliliters of hydrochloric acid and then add it to your styrofoam cup. Remember to always add your acid to the water because it's an exothermic reaction and you don't want to get splashed by acid. As before, we're going to be putting our styrofoam cup into a 400 milliliter beaker and then placing in the probe through the lid. You'll want to check the temperature of your solution because it should be a little bit warmer than ambient, but it will slowly decrease until you get a constant reading, and then you can begin to add the sodium hydroxide, which we'll do next. You will next need 3 molar sodium hydroxide in a small beaker, about 20 milliliters as before. And because we previously used our volumetric pipette for hydrochloric acid, we'll want to rinse it before we use it for our sodium hydroxide. So if you draw up a small amount, you can then rinse the inside of the pipette and then expel that into your waste container. So once your solution has become at a constant temperature, you can then add 10 milliliters of your sodium hydroxide to your styrofoam cup. But don't forget to start the recordings first. So I'm going to start the recordings on the computer and then draw up 10 milliliters of sodium hydroxide and then place it into the cup. You can then close the lid on the cup as the reaction proceeds. You'll want to continue to take readings through the MicroLab software until you see a constant decrease in temperature, because no more energy is being produced from the neutralization reaction. Once that happens, you can then remove your probe from your solution and then dump your solution out into a waste beaker. So after the reaction is done, you can then use the readings that you got on your graph and the ones that you wrote down to calculate the enthalpy change of the neutralization reaction. That concludes Experiment 8, Hess's Law and Calorimetry. Please ask your TA if you have any questions or any problems with this lab, and please dispose of your chemicals properly. Thanks for your attention, and I'll see you in the next video.